Okay, PS10's coming due in the next couple days, and then the last assignment will come out tomorrow or Friday. Any questions or problems about anything? Yes?
Once the game is over, do you want us to just exit or like?
Well, okay, so the question is, when the game's over, what do you do? I wouldn't exit. You could at least just do nothing and let them click new game or something. Yeah. Anything else? Okay, so for PS11, the first deadline will come fast, and that will just be you telling us online whether you have a partner or not, and if so, who it is. So be thinking about that if you haven't already, if you want to have a partner. Okay, we're going to look at a program today, and this is the program. So what it is a really simple paint program. And we're going to work up to this. First, I'm just going to demo what our end goal is. We probably won't even get to the end goal today. And then we're going to start with something even simpler and work our way up. So this paint program will let you pick between drawing an oval, a rectangle, or a line. And you can choose whether to make it red, green, or blue. So if I want to make a blue rectangle, I just click and drag, and it you click in the center and then drag out and create your rectangle. If I want to do an oval, same sort of deal. If I want to make it green, it looks like that. If I want to do a line, make it red, I draw it like that. Okay, so that's where we're headed. And along the way, I want to illustrate aspects of inheritance and interfaces and similar things. Okay. And then there's a menu that closes everything down. So that's this thing, paint, right here. So let's look at paint 1. So down here I have some jar files. These are executable versions, executable jar files that show you what the final version of each version is supposed to be. There's 7 different versions. And so paint 1 is, let's see what it does. It draws blue there, and no matter what I do, I can't get anything else. But as I resize it, you'll see it starts changing what it displays. It's got a blue rectangle there. If I close it down and open it back up, it's a green rectangle now. So, can you think of what would explain that behavior? Why is it changing what's displayed as I resize it, or if I do something like this? So let me get something smaller up. So here's Notepad, and so I take Notepad and drag it over, cover it up. No, that didn't work. That didn't work, but this does. Okay. So think about what you're doing now with lights out. What explains this behavior? What would you have to do to make it display sort of, to make it so it displays something different when you resize it or iconify it, bring it back up? So I iconify it, and the red rectangle becomes a blue line. Any theories? Yeah?
You make it taller whenever it's resized, the shapes.
Okay, so that's a reasonable guess would be that I somehow find out when it's being resized and redraw it. But why is it different every time? Why is the color changing? Why is the shape changing? Yeah?
If you had like a mouse listener, some sort of action being performed every time you reshape and then you're like redrawing it.
Okay, so he's saying maybe there's an action listener or a mouse listener that's figuring out, and every time I change it. There's some randomness involved. There's a random number generator. So here's the bottom line. there's a paint component method, and you've seen paint component methods. Paint component methods, when they're called, just repaint the component. When's a paint component method called? You've probably never written a method that calls paint component. So what calls it? When would a paint component be? When would a method be? The paint component method be called on a J panel, such as the one you see here? Yeah.
So when the button's being clicked.
Well, no, paint component's not called when the button needs to be clicked. Swing does the calling. When would Swing want to paint a component? What would have to happen for paint to decide, for Swing to decide, I need to call the paint component method on this component right here? Yeah.
Like updated movement.
Right, when something changes about the J panel. So, when if the the window's like that, as you make it bigger, it's calling paint component over and over and over again. So Swing just says, oh, the J panel got bigger, I'd better call repaint and let it redisplay. Now there's more space. Whereas it gets smaller. Or you iconify it and bring it back up and it says, ooh, now it's visible again, I better call paint component. Okay? So that's what's happening. Now let's look at our starting point. So right here in the paint one, there's the paint class, which isn't going to change in any of my demos. And here's the paint panel class, which is going to change. So I'm just going to run paint.java here. And what we get is a blue oval, and no matter what I do, it stays in oval, but you see it's changing color. So what we're going to do is start by seeing how this works and gradually build up to what I showed you at the beginning. Let's start with paint. Like I said, it's the same for all the versions we're going to look at. So we just have to look at this once. So let's see what it's got. It has the close menu, which just the action is going to be to close the application. There's a label. I didn't even notice what it does. I don't remember what it does. To create the paint, paint extends JFrame. So we set the title, we set the default close operation, we make a main panel that is going to eventually contain the drawing area. We add, this is a kind of control we haven't talked about before. We're creating a J radio button. So we create 3 J radio buttons, oval, rect, and line, and add them to the shape panel. And then we create, so what is a radio button, a J radio button?
It's just the little circle that you click to fill in or not.
Okay, so a J radio button is these things up here. So a radio button is on or off. You'll notice that what I do is I first add them to the panel so they'll be displayed. And then I create a button group and add those radio buttons to the button group. So what do you think is the purpose of a button group? So these 3 radio buttons up here, oval, rect, and line, are in the same button group. What does that mean? Yeah.
I think that means you can only have one of the items selected at a time within that group.
Okay, so for the button group, you can only have one selected at a time. So this is one button group, and then the colors are a different button group. If we didn't put them in a button group, they'd all be independently selectable, which I don't want.
So they'd all be button groups of 1.
Well, if by default it's a group of 1 if you don't group them. So this is just done to create the radio buttons for the shape. We do the same sort of thing to create the radio buttons for the color. And now we add everything so it's displayed. The shape panel, which is the main drawing region, is added right here. And then the file menu. All right, so that's the only thing I'm interested in for that class. My focus is to be on the paint panel. So the paint panel, when you construct it, you give it the two button groups. And that's what the paint panel cares about. And the constructor just saves them away right here. And then we have the paint component method. So let's see what it does. First we call super.paintComponent of G. And that just says whatever you do by default to draw a J panel, do it now. And by default, all it does is it just fills in the background color for us. This anti-aliasing is just to make the graphics sharper. You'll see here, every time paint component is called, I pick a color at random. So I just generate a random number, 0, 1, or 2, and then based on whether it's 0, 1, or 2, I set the color of the graphics object. Okay? Now I've had you read about switch statements before in the Xi book, but we haven't ever talked about them. So who can summarize how a switch statement works? Okay?
It's basically like an if-else statement where I think like you're matching like the argument that you're passing to your different cases, like you have 0, 1, and 2, and then depending on which case that argument like evaluates to, it does that.
Okay. Okay, that's right. So the switch evaluates that expression right there. In this case, it'll get a 0, or 1, or a 2, and then it just starts with the first case and sees, okay, was the value of that thing right there 0? If it was, it just starts executing statements. If it was 1, it starts executing at this statement. At 2, it starts executing at that statement. Now the thing about case statements, which is kind of weird, if you leave this break out, who could tell me what happens if you forget to put the break in? Yeah?
Is it going to go through all three?
Well, if you don't put the break in the case where this expression evaluates to 0, yes, you're going to execute that, and you're just going to continue executing. So you'll set the color to red, and then to blue, and then to green. So typically we don't, sometimes you want to pass through to the next case, but in this situation we don't, so we need to put the breaks in. And there's you got the equivalent of an else, which I didn't use here. You can put default. So you can have a default case, which goes if none of the above apply. And so we could add a default case. And maybe we say in default, by default, we're going to do g.setColor to black, maybe. Okay, so that's a switch. So remember, this is called every time the component needs to be repainted. So we pick a random color and make it the graphics color, and then we draw an oval. So that's why when we run this one, we always see an oval, but the color changes every time paint component is called. Now, what would it take to change this code so that the shape was picked at random as well? What do you think about that for a minute? Then I'll give you a shot.
We can use a similar switch statement and
Okay.
Random shape.
Okay. So essentially, it's the same idea here. So let's copy this switch. We're again going to pick a random number, and this time though we're not going to set the color. And I don't need a default. Instead, I'm going to draw something. So I'll just copy this code here. Case 0 will draw an oval. Case 1 will draw a rectangle. And case 2 will draw a line. Then we don't need to have this code in anymore. Okay, so I just made a quick switch. So every time the panel is redrawn, it picks a random color and a random shape to draw. So here we go. There it is. As I force swing to call paint component, you see it switching around. Now, just to emphasize what I told you before, what will happen if I take these breaks out? What's that?
Only the line will be drawn.
Well, he said only the line will be drawn, but that's not quite true. What will happen if this evaluates to 2? Yes, only the line will be drawn. What will happen if this evaluates to 1? It'll draw a rectangle and a line, because it'll start here, it'll draw the rectangle, it'll fall through to case 2 and draw a line. But you're right, if the expression is 0, it will draw, well, like I said, what you said either. It'll draw all 3. So let's see the effect. It'll always draw a line. So there, it got a line. Now if I resize it, you'll see there's always that line there, and sometimes it'll have an oval, sometimes a rectangle. Okay? So that's version 1. Pretty simple so far. I'm interested in what you're doing. Let's see.
Oh, sorry. I was looking at the Untitled Java, and I was trying something, and I realized that I initialized it when I was doing a for loop. I set something to I instead of J to create an infinite loop, and that's how my computer
Okay.
crashed.
So you don't have to tell everyone around you about it.
Sorry.
Okay, so let's go to version 2 and see how version 2 differs. So version 2, okay, it's not changing what it draws every time, which is nice. And well, maybe it is. I'm going to change rectangle blue, and then I'm going to resize, and you see it is redrawing everything, but it just doesn't pick at random. So when it needs to repaint, it paints what the user has selected. Okay? So we want to make that behavior happen. So let's go to Paint 2. And now I'm going to show you what the current version of Paint 2 is just what we just did. So it just picks at random something to draw. So before I show you any code, how are we going to achieve this? What's it going to take to change code that randomly picks what to draw into code that pays attention to the radio buttons? Yeah.
Well, you have to get rid of all your switches first.
Okay. So we'll get rid of the random number and the switches, and what do we replace it with?
The radio buttons.
Okay, we've got to start making use of the radio buttons. So instead of using a random number generator to determine what we do, we use the radio buttons to tell us what to do. So if I scroll down, find my mouse, there's Paint component. It begins just as before, and it has the code like before. But I want to show you a method I've written. So look at get color there. So what was color buttons? Remember what color buttons was? Yeah.
Was it the radio group that said the...
Right, so it was the button group for the colors. So if you say color buttons, which is the group, and you say get selection, what you will get is the button that's currently selected. And then on that button you say get action command, and you'll get back either red, blue, or green, depending on what kind of button. Yeah.
What does get action command?
Well, by default, get action command will return the label of the button. But I didn't emphasize this, but when I created the button, I called set action command on it. So when I created the red button, I called set action command and made it red. So that's how you can identify elsewhere which button it was in the name. So you see, I just have a switch still, but it's based on the value of whether it's the red button, the blue button, or the green button that's selected. So coming back up here, what should we do now to use the selected color and the selected shape? Yeah.
Make a switch case with the radio buttons for the shapes.
Okay, for the shapes, but what should we do for the color? So we don't need this stuff anymore. So what should I do to set the color that I want to use to draw with? Okay, so I'll say g.setColor, and I'll just call my getColor method, which will look at the buttons. So that'll set the color appropriately. Okay? What about setting the shape appropriately? I don't want to do this random choice anymore, but I do want to keep the code around actually, so I'll leave it there. What I'm going to have to do, so I draw the oval, the rectangle, the line as selected.
Just be G dot set shape, or whatever it was called.
Well, yeah, there's no set shape method. To draw an oval, I'm still going to have to do that. And I got to choose between these three options. So how do I choose between those three options?
Time to the radial buttons.
Yeah, I got to do a similar thing that I did right here. So I'll copy this code. I'll come back up here and paste it in. But I don't want to look at the color buttons group. I want to look at the shape buttons. And I will get the selected shape button and get its action command, which is going to be not red. The choices there are going to be oval, rect, and line. Okay, and I'm not going to have a default.
Can you even not choose one of the radio buttons to even have a default? Or does one of the radio buttons always have to be selected?
Okay, that's a good question. What if none of the buttons were selected? What would
Is that impossible?
It's possible. When you first create the group, I made sure to make sure one was selected.
Oh, so by default.
Yeah, so I don't think in this program there's any way to not have any selected. But if it were, we would probably want to have a default. All right, and then what we do is, if it's oval, we just do this. And if it's rectangle, we do this. And if it's a line, we do that. And we need to put in the breaks so we don't draw 2 or 3 things. And that should work now. So let's try it out. And every time I resize it, it draws something, but it draws the same thing. So you don't see anything changing because it's just drawing the same thing. But if I switch that, then next time I cause paint component to happen, we get that. So I can now choose what color and what thing is displayed. All right. So not where we want to be yet, but we're making some progress. So that's first 2 versions. Any questions I could answer about those? Yeah.
So when you wrote that, I know you didn't put a break on the last one. Is that because it's basically acting like if else and else? So the first 2 are eliminated, and it's automatically the
Okay.
last one by process of elimination.
Okay, so it's basically asking about the absence of a break right here. So strictly speaking, this break is redundant, right? Because if you don't have it, if you go to case line and draw a line, you're going to run off the end of the switch and just continue normally anyway. It's as if there was a break there. But it's actually a good programming practice to put a break there anyway, even though it's completely redundant. Why would that be? Yeah? Okay, so what she said was, suppose I now go add another case. I might, if the break weren't there, I might, it's easy to forget to put it in. So you just sort of put it there so that if someone pastes another case below, there's a break above it. It's not a big deal, but it could solve a problem prevent a problem from happening every now and then. Okay, other questions? Yeah.
Can you bring back up the shape drawing thing and resize it? Just want to see something real quick.
Okay, so just run this program.
Yeah, because I'm wondering if the X and Y coordinates, are those in relation to like the little window once it pops open, or like your screen regardless of where the window is?
Well, what X and Y coordinates are you talking about? Oh,
Where
these
do you
here?
draw the shape from?
Okay, so let's talk about this. So draw oval, what I'm saying is draw at X coordinate 200 and Y coordinate 100, something that's 150 pixels wide and 250 pixels long. Okay?
So that's your screen, your small.
Right, so that refers to, this is the origin up here. So it refers to this white area. It refers to this J panel. So the coordinate system for the J panel starts in the upper left-hand corner, and X goes across in this direction in pixels, and Y goes down. So that's why this thing is like 200 over and 100 down to get to its center.
So if you move if you size the screen to the right, does the circle stay in place? Or
Yeah, as I go to the right, it stays in place because my origin isn't moving. Now if I go to the, I don't know what happens if I go to the left. I haven't tried that. It should track with the edge of the, right, because it's always drawing it at the same place in relation to the upper left-hand corner. Other questions? Yeah.
So if we wanted to move, let's say like left or right, would we have to use a logic similar to what we did in the animation?
Right, if we wanted to move left to right, so for example, we could do something like this. Let's say, I'm going to create a new instance variable real quick here. Int delta equals 0. And then down here, when I draw it, I'm going to do 200 plus delta. Actually, I'll do it this way. Yeah, you wanted to ask that. So I'm going to add delta. I'm going to add delta to that. And then when we're all done drawing it, I'm going to say delta plus equals 10. So what will happen now when I cause it to repaint?
Would you say plus equals 10?
Yeah, plus equals 10 is what I meant, yeah.
Every time the x-axis will engage with it.
All right, it's going to drift to the right as it's redisplayed. So I'll run it, and then what you'll see is that as I move to the right here, and it doesn't move to the left, doesn't recover it. I can't catch it now. Okay. So that's just an animation in action here. So even if I pull down, anything that causes it to resize is making it move because delta keeps getting bigger. But I'll leave it in. I'll comment it out in case you want to look at it later. And I guess I should for instance variables ought to be private. And well, shoot, I'll just leave it in. Any other questions? Okay, let's try a different one. Now we'll look at Paint 3. So this is where we want to be at the end. So I've got this set up, and when I click, I get a red. In this case, is a circle where I clicked. If I click somewhere else, I get a red circle there. If I change up here and ask for red, green, so I'll get a red rectangle, or I can ask for a blue line. So it's not letting me pick the dimensions of the shapes, but it's letting me pick the position. And furthermore, if I resize or I conify and bring it back up, whatever, nothing changes. That's what you expect of the application. So let's think about this. How do we cause this effect? So, yeah.
So would it be a combination of radio buttons and like a mouse system?
Okay, he said would it be a combination of the radio buttons? So yes, the radio buttons are still necessary to decide what color and what shape. He mentioned a mouse listener. So where does a mouse listener come in on this?
Origin.
Okay, the origin. So I need to find out when the mouse button is clicked, I need to know it was clicked first of all because I got to draw a new shape. But I've also got to know where the mouse was clicked so I can know where to center the shape. What's the origin of the shape? So this is going to involve a mouse listener. So let's look at it. So here we are, Paint 3. Let me run it. And let's see. Okay, so it's in the same shape. It's basically doing the same thing that Paint 2 did at the end. So let's look and see how to fix it up. So first of all, what do you suppose those three lists are for? What does this version of the program have to do that the other ones didn't?
Multiple drawings at once.
Okay, we got to keep. The other ones just drew shapes. we have to remember the shapes so that every time the screen is repainted, we know which shapes to repaint. So somehow we got to keep track of what ovals, rectangles, and lines there are, so we can draw them. So here I have created 3 lists: a list of the ovals that the user has drawn so far, a list of the rectangles, and a list of the lines. Okay? And here I just set them to empty. So every time when the user clicks and displays a rectangle, information about that rectangle is added to the rectangle list. When they create an oval, that information is added to the oval list. So right off the bat, we've been talking about generics. So this is an example of using an array list of 3 different types of things: array list of ovals, array list of rectangles, array list of lines. So where will these classes come from? Oval, rectangle, and line. They're not in the Java library. What's that? I created them. Right. So let's go look at them. So down here at the bottom, here's the oval class. So you'll notice an oval has the x-coordinate of its center, the y-coordinate of its center, the radius in the x direction, the radius in the y direction, and a color. So it has 5 instance variables. The constructor right now just takes in x, y, and color, and the radius is just set to 100. We'll fix that eventually. And then it provides a paint method. So this paint method just knows how to draw an oval of a given color. So every time when you call the paint method and give it a graphics object, it sets the color and draws the oval at the appropriate spot. And the other classes aren't much different. There's a rectangle. It also has a center and a color and a width and a height, as opposed to a radius, and a paint method. And line has same thing, except it doesn't have a center. It has a start and an end, and a paint method. So we got these objects that represent individual shapes and know how to paint themselves on a graphics object. So how are we going to make use of these classes besides creating a list of shapes? When will we add something to this shape, to this list? How will we know it's time to create a new oval and add it to the list? Okay, when the mouse is clicked. So how are we going to find out if the mouse is clicked? Right, we have to come here and say implement mouse listener. All right, so now we're looking at implementing an interface. So we're using that aspect of Java in here. And you'll know that when we do that, it's going to complain that we haven't implemented the methods we're supposed to. So I'm going to say add unimplemented methods. And down here at the bottom of the class, it's added in mouse clicked, mouse pressed, mouse released, mouse entered, and mouse exited. Yeah?
If it ever does a thing you did last lecture where it doesn't give you that option, you just like find what those are on like Java Oracle library thing.
Sure, yeah. If you can't get Eclipse to auto-generate these for you, you have to go go to the documentation for the mouse listener interface and copy and paste from it, or just write your own code. It's kind of tedious, but it's not impossible. So mouse exited is going to be called whenever the mouse enters our painting area. We don't care about that. And mouse exited tells us when it leaves. Mouse pressed tells us when the button goes down. Mouse release tells us when the button comes up. When you let go of the button. And mouse clicked is some combination of those. So we got to pick one of these to implement. So do you want to go with a click or a press? I think with pressed, you could press it and then move the mouse and then press it. That would cause the event. With clicked, you could probably press it, move the mouse, and release it, and it would register where it was after you moved it. Doesn't make that much difference, but we'll go with clicked because it's on top. Okay? So we got the mouse clicked method. So what do we do in the mouse clicked method?
Get the coordinates.
Okay, we got to get the coordinates. We got to find out where the click occurred, and that's easy. Let's do int x equals, and the event has a method called getX. So we can just ask the event, what was the x coordinate? Now it has other interesting, it also has a get button and get click count, get modifiers. What do I suppose those are for? What would get button be? Yeah?
Maybe you have like different buttons, like a new game button and a manual setup.
Okay, so it's, yeah, so but that's a reasonable guess that it's talking about buttons on the screen, but it's, what's it talking, what kind of buttons? Yeah, the left and right buttons on the mouse. Or if you're not using a mouse, it would be, did you left click or right click?
Should you use get source then for what I said?
Get source?
Yeah, like would that return the button you click?
No, get button returns that. So get button returns a code that tells you what button was clicked. Get click count would let you detect double clicks or triple clicks.
Sorry, from a J button you're talking about.
Yeah, for a J button, yeah, but we're not. This doesn't involve J buttons. Get modifiers would tell you, like, was the shift key down when you clicked, the control key down when you clicked. But we don't care about any of that. We just care about get X. And get Y. Okay, so we know where the event occurred. What do we do with that information? Yeah?
You make a shape at that point.
We make a shape at that point. Which shape?
Whatever's selected by the radial buttons.
Okay? We need to involve the radio button. So I'm going to come up here and steal this code, which we're going to change eventually. But this is the switch we need. So I'll copy that switch and bring it down here. And what I don't want to draw an oval, I want to create an oval object. So I want to call new oval, and we want to do X, Y, and color, and we can get the color by calling our getColor method. So that creates an oval object that's centered at X, Y, and has a particular color. So that takes care of the radio buttons. What do we do with this oval? What's that?
Would you want to add it to the list? So
Right, so we had a list up there called ovals, so we can just say ovals dot add new oval. Okay, and then we basically do the same thing here. Well, that has to be a rectangle. And did I call it? I think I spelled it, gave it a long name there. And then lines dot add line. Okay? So we just add those lines. So that's when the mouse is clicked. What needs to change up here? This is the our familiar paint component method. What do we want to change there? Go ahead.
would you want to iterate for your three array lists and draw all those objects?
Okay. So every time it comes time to paint the screen, paint this J panel, I need to paint all the ovals, all the rectangles, and all the lines that we have in our list. So we don't want to draw just one every time it's called. So we don't want this anymore. We're going to have to set the color. Well, actually, we don't set the color. So let's iterate. So for each I'll call this oval. All right, so we iterate through our list of ovals and do what? How do we paint it? What's that? Right, there's a paint method I showed you. So we'll just ask the oval to paint itself using this graphics object. So we paint the ovals, we paint the rectangles, Is it called rects? I was inconsistent how I named things. We paint that and we paint the lines. Okay, so let's think about what we've done. We have we fixed it so that when anyone clicks, we create the appropriate shape of the appropriate color. And then whenever the thing needs to be repainted, we just paint all the ovals, then we paint all the rectangles, then we paint all the lines. So let's see how that works. All right, nothing's there at the beginning. That's good. So I got oval red. I'm gonna click, and nothing showed up. I'm gonna resize. Yeah, that's not what was supposed to happen. Okay, what have I done wrong? I made two mistakes. One I knew about. Yeah.
Do you have anything in mouse click?
Do I have what?
Do you have anything under mouse click?
Well, I have the mouse clicked. Maybe it should have been a mouse pressed. Let's try that. Yep. Okay. Well, this is concerning because I'm not quite sure why nothing's showing up. So let's go through it again. Help me out here. We declare the lists. We initialize them to empty lists. When it comes time to paint, we paint the ovals, we paint the rectangles, we paint the lines. And every time the mouse is clicked, we add to the list. So, yeah.
What is it called to paint?
Say again.
What is it called to paint?
When does what call paint?
Or when is this called to actually paint the object?
Well, down here, these objects paint, sets a color, and then draws an oval in the graphics context. So what I find is there's this overwhelming desire to be paranoid, but probably what's happening is mouse clicked isn't being called. Isn't that the most logical explanation? When it's definitely painting all the lists of shapes. The list must be empty. Okay, I now realize what I did, but I will continue as if I didn't. So let's do that. Let's check and see. It ought to be, every time we click, we got to get click printed out down here somewhere. So let's go here, and I will click. All right. So we're not registering the clicks. Right? Anyone else figured it out yet?
Yep.
What?
I added the mouse listener on it.
Right. I didn't add a mouse listener to the. Right. So I need to come here and say add mouse listener this. Okay. Now we'll get notified. So let's do this. Okay, so it registers the click. I'll change to rectangle. It registers the click. It should have. What the heck? Okay, I said I didn't really click it. And I'll add a green line. Click. But nothing has shown up. But, there they are. I had to resize the screen to force the paint component to see those things. If I create a blue oval, I see nothing. If I resize it, okay, really click. There it is. Okay? So what's the problem? Yeah? Right, I have to resize. So I want paint component to be called, but the only way I know to do it is to resize the screen. So we need to do something when we add something to the list here. We need to force paint component to be called from this mouse clicked. And I'll just tell you the way you do that. If you want swing to repaint something, you just call repaint. That's the correct way to do it. You're advising Swing that this thing needs to be repainted, and in very short order, it will call repaint. It'll repaint it, which involves calling paint component. So now, with that repaint in place, now I click the oval and it shows up. I can add that. I can add that, and when I resize it, it looks the same. Okay. So that's good. Now, there are two ways we could go now. I could, I need some way to resize these shapes, so they're not always the same shape, same size. But I want to look at something different. I want to think about the code here. What do you think about having 3 lists? So we have separate lists for ovals, rectangles, and lines. That means that from the constructor, we have to initialize them all. That means that when it comes time to paint them, we have to have separate for loops for each one. And yet, the shapes are all virtually identical. If you look at them, the shape class, the oval class, has a constructor that takes XY color and provides a paint method. Rectangle takes XY color and has a paint method. Line takes XY color and has a paint method. How can we simplify this? Yeah?
You could make like an interface called shape or something.
Okay.
So that will implement it.
Right. So what we're going to do after we take a break is add a shape interface that describes what these classes have in common. And then we won't need 3 lists. We can have a list of shapes. And we can have a loop that paints shapes. So it'll make the code more streamlined. So let's take a quick break, and then we'll look at our next step. right, so now we're in the fourth version. And the fourth version is going to behave exactly like the third version, except we're going to improve the engineering a little bit. Now, you've probably heard the saying that goes, if it ain't broke, don't fix it. So, is this a good idea to go take a working program and change it just to make it, a simpler implementation? What do you think? Yeah, as a rule, if it's working fine, you don't want to mess with it. What would be the argument for doing it? Yeah.
It's using too much memory stack.
Well, okay, so you said maybe it's using too much memory. I don't know if that's the case here. It could be a case in certain circumstances. Yeah?
It may perform faster if you make it more streamlined.
Perhaps it could perform faster if it's more streamlined, but that's not my main fault either. Yeah.
It'll make it a lot easier to modify if we want to
Okay.
add on more types of shapes. And
Right. So what he's saying is, okay, it's fine the way it is, but imagine that you're thinking of expanding in the future and adding new types of shapes. Right now, as it stands, to add new types of shapes, you'd have to, have to declare new lists, and you'd have to have a new loop. It'd be nice to be able to avoid that. So for future growth, let's just fix the problem now so we won't have that problem in the future. So what we're going to have to do is create a shape interface that captures what these three classes have in common. You got a question?
So would this interface kind of be like a helper method, but instead of a helper method, it's a helper interface?
Oh, you're trying to compare the interface to a helper method?
Yeah.
That's sort of like a helper class, maybe. Yeah, except it's an interface. All right, so I'm going to come down here where the classes start, right there, and we're going to have to declare an interface. So let's just stop there. So we have an interface shape. So my goal is to come up here, and instead of having three lists, I just want one, an array list of shapes. Okay? And then right here where we initialize we'll do that. Now before I delete this, there is something going on here that's more than just reorganizing the code. There's actually a problem in the code as it's written that's going to be solved when we just have one list of shapes. It's a very subtle bug in the code. Just the difference is in how it looks, how the shapes actually look when they're drawn. Can anyone see what that is? Why would it matter if this is going to draw all the shapes sort of in one loop, as opposed to drawing all the ovals first, and then all the rectangles next, and all the lines after that? Yeah?
Does it draw them in order of layers?
We're going to be drawing them in the order. We'll start with the oldest shape and go up to the newest shape. So what difference will that make? Drawing them in order instead of by shape, yeah?
Would it be like the layering?
Yeah, the layering effect. So if you have, an oval that's overlain by a square, the lines for the square are going to be continuous. They'll be on top of the lines for the oval. It's not a big deal. It would be a big deal if we filled these things. Then the layering would be really observable. This way, we'll get the layering right. So anyway, one array. What do we have to do to paint all the shapes? Well, we just have one list instead of three. All right. We'll get rid of, we just need one loop. And what will it look like? Yeah. A lot of shapes there. So we'll just paint each shape. Okay? What about down here? Now, unfortunately, we're still going to need some way of deciding which type of thing we actually want to create. So we're going to have to say, okay, create an oval, create a rectangle, create a line. But where are we going to put the thing? We're not going to add the oval to an ovals list. Where are we going to add it to? Shapes list. Okay. And okay, so we've got some problems. Let's go up to the first problem. It says the method paint is undefined for the type shape. Okay, so what's it telling us there? Yeah?
For your shape data type, there's no method.
Right, our interface is empty. So we need to add to the interface this paint method as expecting. All right, so now there's a paint method, so we're saying a shape is something that knows how to paint itself, basically. That fixes one problem. But then we got these three problems, and it says the method add shape is not applicable for arguments oval. So it's just saying, hey, you can't add an oval to a list of shapes. You can't add a rectangle or a line to a list of shapes either. Okay? So what's the problem? Yeah? Right, they're different types. Right, you can't add, an oval is completely unrelated to a shape. You can't add it to a list of shapes. But we want to do that. So how do we establish a relationship between ovals and shapes to make this fly? Yeah?
Your oval class implement.
Right, we have to come down here and say, okay, oval implements shape. Okay? And do that for our classes. Now, it can implement shape because, lo and behold, it has a paint method here, like it's supposed to have. And for completeness, I'm going to say this overrides the, again, that's totally optional, but it's just a good practice. Just to remind ourselves that there's something special about this method. It overrides a method declared in the interface.
The method isn't actually implemented in the interface at all. It's just a method stub.
Right, the interface, it's not even, okay, the interface doesn't even contain a stub. It just contains the header. I'll go back up there in a second, and then we'll say this implements shape. Great. So back up to the interface. Where is it? You'll see it just, semicolon at the end. So a stub would look like this. But it doesn't like that. You can't put a stub in. It's got to be that. Now, this is completely an aside. No one's asked me yet why I don't say public interface, public class, and so on. Who knows why? Well, the explanation is simple. You can have, you can have you have to have exactly one public class in a class file. And the class file has to have the same name as the class. So paintpanel.java contains a public class called paintpanel. These other classes aren't public, which means they won't be visible. I think they're not visible outside the package. So what if you wanted these classes down here to be public? Suppose you decided this shape interface is really important and should be public so people can use it, and the oval class should be public. What would you have to do? Yeah?
Could you just throw on public there, or do you have to put it in a file?
Yeah, you can't throw a public in because there's only one public class per file. So if I did that, it's going to complain. You'd have to create an oval file. You'd have to copy create separate file for every class. And that may or may not be a good idea, but for today it would be kind of a pain. There would be too many files. So I just stuck them all in one file. Yeah?
Private or protected?
Without anything in the front?
Yeah.
Okay, so if we say it's not public, because we didn't say so, it's not private because we didn't say so, and it's not protected because we didn't say so. If you don't say so, it's called package level protection. Means it's visible in its package.
Isn't that what protected means though?
No, protected has to do with inheritance. And we'll see an example of protected shortly. So this is a fourth protection, the default, if you don't put a word there. Okay, all the red has gone away, and if we run the program, it works like before. Okay? And we sort of simplified going to this version by taking advantage of interface. So we created the shape interface, which streamlined our code, and it would really streamline it more if we started adding more different kinds of shapes to the system. Okay. Any last questions before we move on to the next one? Let's look at Paint 5 and see what it does. Okay, so it's behaving exactly the same way. So this is another case where we're going to improve the engineering slightly. So let's look at Paint Panel as it exists. Well, so I don't forget, we'll do this one here. Okay, there's Paint Panel. This is what we just wrote. It's got this loop. It's got the get color. It's got the mouse press to do the right thing. It requests the repaint. These comments are good to put in so people won't think that you just forgot to implement it. Can you think of any way to simplify this? Yeah?
You could have like a base class, and then
Okay, you said have a base class for what?
shape.
Okay, so what he's suggesting is, instead of using an interface, instead of having oval implement shape and rect implement shape and so on, we could have them extend a shape class instead. Now, think about it. What would that buy us? What can you do with an interface that you can't do with a shape? I mean, sorry, wrong way around. What can you do with a class that you can't do with an interface? What would be the advantage? Yeah?
You can have real functioning methods.
You can have real functioning methods. So what you can do is take code that commonly occurs in all three classes and just put them in the base class. So take common functionality provided, or just common stuff that appears in all three of our classes and put them into a shape class, thereby simplifying the three classes. So what do these all have in common? Let's look. An oval has these 5 instance variables: center x, center y, radius x, radius y, and color. It has a constructor and paint. Okay, here's a rectangle. It has center x, center y, color, width, height. And here's line. Start x, start y, color, index, end y. Okay, the constructors are all look the same. XY color, XY color, XY color. So how could we use a class? So if I come here up to shape and turn it into a class, what could we, how could we refactor to take complexity out of these three classes and put them into the base class? While you're thinking about that, I'm going to change this to extends. So I'm going to extend the base class instead of implementing an interface. Just a decision I made. What can we extract out and put up here in the shape class? Yeah.
Like an origin XY coordinate and a paint method.
Okay. So we could take, they all have a color. So we can move, that is, we can move these instance variables up. Every one of these classes has an instance variable called color. And they call them different things, but there is, they have a center x and a center y. There, a center x and a center y, start x and start y. So let's just call those things x. So my idea is, up here in shape, we're going to say private int x, and we'll say origin x. Okay? So put those instance variables up there. We need a constructor to initialize the instance variables. So let's do that. Let's go to source, generate constructor using fields. Okay, so there's our constructor. And we need a paint method. But I don't know what to have it do, so I'm just going to put a stub there. All right. Now, you'll notice that the only red marks are down. The code up here is perfectly happy with the change I just made, because it still sees there's something called shape that has a paint method, and furthermore, that an oval is a kind of shape, a rectangle is a kind of shape, and a line is a kind of shape. So the rest of the code up above is happy. The code down here, there's going to be some problems. So it says here, implicit superconstructor shape is undefined, must explicitly invoke another constructor. What does that mean? What obligation do the oval class have to observe now that it has a base class to worry about, or a base class other than object? Yeah?
Does it have to like put the base class within oval?
Say it again.
Kind of like an interface, but it has to extend the shape class in some way within that method.
Well, I'm talking specifically about constructors. Yeah.
You have to call it a
I need to call a base class constructor. By default, it tries to call the no argument constructor in the base class, but this base class has no zero argument constructor. So we have to do super, and we'll pass up x, y, and c as the three parameters. And we're going to say, do the same thing here. And the same thing here. Now, so far, we haven't made anything any simpler yet. We've just added more code. So when we call, what happens is when you go to construct a rectangle, say, you call the constructor, you give it x, y, and color, and first thing it does is call the base class constructor, and here it is, and it saves x, y, and color in those three instance variables. Good. Same thing happens to the other classes. How can we simplify those other classes?
Get rid of the center X, center Y, and color.
Hold on a second. Yeah. What's that? Oh,
We just delete those three
right.
parameters that were in the
So we don't need this anymore. We just need, we'll keep track of the width and the height. We're not doing anything with the width and the height anyway right now. But we'll keep those separate. We don't have to initialize those instance variables anymore. So what all these shapes have in common is they have an x, a y, and a color. And we're letting that be dealt with by the base class. So we don't have to worry about it down here. Okay? So we got rid of those. We get rid of these here. I think I did it. Okay, almost. Get rid of it for oval. Okay, so I've got two instance variables left there, two there, two there. Now, let's see what the problem is. It says there, change visibility of color. The problem is the color is not visible. Right? So what's going on here? Before we had an instance variable called color, and we could just set the color to it. Why is it not visible now? It's defined in the base class. So somehow we need to get the color from the base class. We inherited, the rectangle will contain width and height. It will also contain origin X, origin Y, and color, but they won't be accessible because they're private. The only things that can operate on those private instance variables are methods up here. Now, let me show you one way to solve the problem, and I'll tell you why it's not a good way. So I'm going to take the suggestion that is given here. It says change visibility of color to protected. So now it says protected instead of private. What protected means is this variable can now be accessed from inside of the shape class, but it can also be accessed inside of derived classes. So that means that the oval class can get at the protected variable. The outside world can't see color, but the classes that extend the base class can see that. And while that solves our problem, it's the wrong thing to do. Okay? Not everyone would agree with me, but that doesn't matter right now. Why is it wrong? Why is it wrong to make that variable visible in the base class, in the derived class? What hard and fast rule does it violate? Yeah?
All the instance variables should always be private.
Right. All the instance variables should be private. There are good reasons for making instance variables private. And if you make them protected, then suddenly, what was the main reason for keeping instance variables private? Well, a simpler way of putting it was, so you can change them. Once you make them protected and people start extending your class, suddenly you're stuck with them. You know, people are depending on them. So that, I'm going to undo what I just did. We don't want to make instance variables private. I mean public, protected. We're going to keep them private. So I'm going to try another suggestion. It says create getter and setter for color. Let's try that. I really don't want a setter. And I'll say, okay. Let's see what happens. So let's go see what it did up here. It added a method called getColor. Now, I don't agree with that solution either. Well, maybe I don't disagree so much with this. But I don't want to change shape to have a color method. So I'm going to change the protection. I don't want getColor to be visible to the outside world for some reason. So what do I need to do?
Make that private.
We make this protected. Okay, so sometimes when you're creating a base class, you create methods that are intended to be used by the derived classes, but not by anybody else. That's what protected means. Don't make your variables protected. Make your methods protected. Yeah?
If you made that private, could you call super getColor? Would that work? Or would it still not be accessible?
Now, if you make this private, you wouldn't be able to call it.
Even through super?
No. Super won't bypass that. Okay. So now we've got center X. So just to finish this up, let's see, I'm lost. Where am I? Shape. Let's add a method called, now I'm having to work harder than people do when they're willing to make a instance variable protected. But that's just the price to pay for being right.
What's like the other side of that argument?
The other side of the argument is it's a pain to write these getters. Okay, so I had to write those getters because I refused to make the instance variable private, protected. Okay, and down here, whenever I say center X, what should I say? Get X. Well, I'll call the get X method, and I'll call the get Y method. That's good. And down here, we'll call get X and get Y. And down here, we call get X and get Y. Now, you may be thinking that this is an awful lot of trouble to go to. These classes aren't that much simpler than they were to start with. And that's true. But I'm just trying to get the idea across. In a serious system with lots of derived classes, this can start to make a huge difference. Anyway, I have reorganized things so that every class extends a base class. The base class keeps track of the origin information in the color. It provides getters to obtain that information. And the bottom line is we broke it and now we fixed it so that it works like it used to. And we've simplified it somewhat. So the next step, I'm not going to try to do that today, is to add the functionality that lets you, let me remind you. I will run this, is to be able to create, when you click, it creates the shape, but then as you drag out, it changes the extent of the thing. So if I create an oval and start dragging from the origin, the radii become bigger than 0 until I release. So we're going to need to do that, and as we do that, we'll explore a few more ideas about object-oriented programming. So let's end here, and we'll pick this up next week.
Don't need to know this.